Hi everyone. As we studied in the previous class, the various forms of propagation of errors. We know that the propagation of errors is also called as a combination of errors. Those are the following types. In that first type, we discussed in the yesterday's class regarding with the errors which is propagated due to addition and subtraction. Now, in this class, we have to go with the errors in multiplication is also called as a product and division is also called as a quotient. So those phenomena, how the errors are propagated, those we are going to be calculated. But before to go with this analysis, we have a small question over there that while explaining the errors, always we are mentioning why there is a plus or minus sign is written. We have a lot of questions over here. Why plus or minus is written? Why not directly we write as a plus and minus? For example, imagine here we have a measuring instrument. This is we call as a device. Any device you can consider. This is we call as a measuring device. Okay, this measuring device is going to be measures a length. This is going to measure what? Length. Here, each value, the least count, you see here, how much it will measure? There is a centimeter, then centimeter, centimeter. It means one division. The one division which will measured by this scale is what? 1 centimeter. Similarly, here, the least count of a stopwatch or a least count of a watch is how much we have? 1 second. It means the least count, the minimum value which can be measured by any measuring instrument is called as the least count. Similar to this, why we should go with this plus or minus? Now imagine, here we consider a meter scale. This is we consider a meter scale. On this meter scale, this will measures compulsorily. Here, when your measuring instrument measures, there is a 1 inches. Say for example, this is 1 inch. This measuring instrument. So this is the measuring instrument. It will start to measure about 1 inches. This is 1 inch. Each unit will be 1 inch. Each unit 1 inch. Each unit 1 inch. So that's why here we consider this is 4 inches, 5, 6, 7, 8, 9. Of course. Now this measuring instrument will going to measure. This is 1 unit. This 1 unit is called as what? 1 inch. It means there is no fraction is obtained here. But while measuring any material or any physical quantity, you know very well the physical quantity. Anything which can be easily measurable is called as a physical quantity. Similar to this, if I measure any quantity there, whose value, imagine whose value, if it is lies after measuring, if it is lies or in between the 6 and 7. So in between the 6 and 7 and 7 and 8. Then here, if it is lies, because it only measures 1 unit. See, after it measures 1 unit, if it is lies here, then how I can mention the value? Then what you are going to say that, oh sir, it is going to be half over here, and this will be half. Half of this will be here, and half of this will be here. And half can be written as what? 0.5. And this will be written as 0.5. Then how I can mention this? This value either may be lies as a 6.5, or I can write this one as a 7.5. 6.5 or maybe 7.5. But how I can write this? In terms of addition or maybe in subtraction. The value which is lies here. Then you can write this is 7 plus or minus 0.5. 7 plus or minus 0.5. It means 7 plus or minus 0.5 means, see, 7 plus 0.5 is equals to how much you get? 7.5. 7.5. If I minus it, how much you get? 7 minus 0.5 is equals to, this is 6.5. Or it means the approx error, we are talking about there is an error, the mistake while measuring. This is the 0.5 of error we got. Because of this reason, what we mentioned, the plus or minus. Because of this reason only, we mentioned there is a plus or minus. Hope you understand why plus or minus sign is going to be written here. The error which is going to be eliminated. There is no perfect instrument. We are told. But there is slight error will be there. That error will be minimized by various methods they are going to be applied in the previous class. Now, we go with the next process, the next method. The next method is what we call the error in the product. Error in product there. Put on the next heading. Error in product. Error in product. Yes. Error in product. So product means, again, it's a multiplication factor. For example, if I have, there is a small rectangular slab. So this is we call as a rectangular slab we have. For this rectangular slab, we measured the length and breadth. So the length and breadth, this is we call as a area. The length and breadth is called as what? Area. Area of this slab is given as in terms of meter square. It means it's a product of two physical quantities. Similarly, now the product which is going to be the corresponding, the equating unit which is equals to, for example, I will write this one as x equals to, this I will write as a and this is b. Of course, you can take any parameters. In textbook, it is given as what? Z is equals to capital A and capital B. You can take either this one or this one. Doesn't matter. The result will be same. You can get there. And I will go with this x equals to A and B. Therefore, now I will simplify this for in terms of for errors in product. Okay. The product is also going to be called as errors in multiplication. Let's do this. So x equals to AB. X equals to AB. Equation 1. We call as equation 1. Then A and B are the two physical quantities. A and B are the two physical quantities. Then error associated with A and B. There is a errors. We know that yesterday we have been discussed. There is an absolute errors which is going to be associated with A and B during the measurement. If it is associated with A and B, then also associated with the X. The result is also associated with certain error. Then I can write this value as a X plus or minus delta X. This is equals to, this is A plus or minus delta A into bracket. This is into B plus or minus delta B. We got this condition. This is for error in product, where A and B always represent the physical quantities, and delta A and delta B will represent what? Its absolute errors, and this is the corresponding result we got. Therefore, now here, if I take x as a common in this one only, just remember, in this bracket, if I take x common, what will be remaining the term you see here? If I take x common, then x will be taken outside. 1 plus or minus delta x as it is, divided by what will be having? X. That's all. How it is? So is it wrong or right? How I can come to know that? So simplify, just to take inside again. Okay, I will just simplify this. X plus delta x into x divided by x, x cancel, x plus or minus delta x. Again the same result. There is no change. There is no change made to the any physical equation. Just we are changing the terms which is related to the numerator. Okay, if I take this term outside x, then what I get? 1 plus or minus delta x by x. Similarly, if I take this a outside, what are going to be remains? Again the same process. A will be taken outside. 1 plus or minus delta a by a into, what is the term again? Here b, 1 plus or minus delta b by b. That's all. Then simplify this. X into 1 plus or minus delta x by x is equals to AB, as it is AB, into bracket 1 plus or minus delta a by a into 1 plus or minus delta b by b. What is AB? From equation 1 you see here, the AB is the product of X it is. Then I can write AB as a X into 1 plus or minus delta X by X is equals to X into 1 plus or minus delta A by A into 1 plus or minus delta B by B. Then you see X from LHS and RHS will be cancelled. The term which is remaining over here is 1 plus or minus delta X by X is equals to, multiply this 1 to this bracket, delta A by A to this bracket. What do you get now? 1 ones are 1. Then plus or minus 1 into delta A, delta B by B. Delta B by B. We got the first term. Then plus or minus delta A by A into 1 delta A by A. Plus or minus delta A by A into delta B by B. Then you see plus 1 from RHS to LHS. You replace this plus 1 from RHS to LHS. Then what do you get down here? If I am going to replace this term from LHS to RHS, sorry, RHS to LHS, then what do you get now? See, 1 minus 1 plus or minus delta X by X is equals to plus or minus delta A by A plus or minus delta B by B plus or minus delta A by A into delta B by B. Then you see the term which is going to be plus 1 and minus 1 will be get cancelled. So this will be get cancelled. The remaining term is plus or minus delta X by X. Delta X by X is equals to, then you take this common here, plus or minus delta A by A plus delta B by B plus or minus this delta A by A into delta B by B. I will use the simple method over here. This term delta A by A, delta B by B is a very small term. You see, delta A by A, delta A is called absolute error. The error is already very small. For example, 0.01 is the error we have. Imagine 0.01 is the error, and this value will be 2. For example, if this value will be the mean value or a true value will be 2. Then divide this once again. Is it getting a huge value or very small value again? Again we are getting, how much is the value we can get there? 0.01, 0.01 divided by, it's a 2. What do you get now? Again 0.005. 0.005. Is it greater or a smaller value we get there? Again a small value we are getting there. Hence, this value is become very, very small. Delta A and delta B. This value is very small. Because of small value, we are neglecting these terms. Neglect these terms. Then what we get now here? Delta X by X is equals to delta A by A plus delta B by B. This is we call errors in product. We call as errors in product it is. Or in textbook, according to your textbook, what they have been given here, this is given as overall. You can also write this. This is delta Z by Z is equals to, this is delta A by A plus delta B by B. This is your according to your textbook. According to the textbook we have here. And this is the parameters we prefer for the making simplicity. As a simplicity purpose, we use the same simple notations over there. And according to the textbook, delta Z by Z is equals to delta A by A plus delta B by B we have. And what is the rule for this? What was the rule which is going to be applied for this? The rule which is applied for the maximum fractional error. It is also called as a fractional error. The maximum fractional error. The maximum fractional error, for maximum fractional error which is obtained in the given product rule. The maximum fractional error in the product of two quantity, maximum fractional error in the product of two quantities equals to the sum of fractional errors of is equals to the sum of fractional errors of individual quantities. Fractional errors of individual quantities. Remember, this is we call errors in product. Okay. Hope we got the complete idea regarding with errors in product. The first we consider there is an x equals to AB is the corresponding product of an given value of a physical quantity. Then error associated with this value is x plus or minus delta x, and error associated with A is A plus or minus delta A. Similarly, error associated with B is how much? B plus or minus delta B. Then taking x as a common, we get 1 plus or minus delta x by x, which is equals to A common 1 plus or minus delta A by A. Similarly, we took there is a B common 1 plus or minus delta B by B. Then AB is also called as what? The given equation 1. From equation 1, AB is written as what? X. And from LHS and RHS and LHS, what will happen? The x value will be cancelled. Then what we have? 1 plus or minus delta x by x. This is equals to 1 plus or minus delta A by A. Then multiplied to this bracket, we get there is an 1 from RHS and LHS will be cancelled. Then we get plus or minus delta x by x equals to plus or minus delta A by A plus or minus delta B by B plus or minus delta A by A into delta B by B. Guys, remember this term we are neglecting here because of what? Very small value. The errors of this value is already small, and divide this value with again a true value or a mean value, you will get again a very small value. Because of this reason, we are going to be neglecting this value. Hence, we are getting there is a delta x by x is equals to delta A by A plus delta B by B. The rule will suggest that. What is the rule will suggesting here? The rule suggests that the maximum fractional error associated with the product of a two physical quantity. Remember, the maximum fractional error. This is we call as a fraction. Okay, the maximum fractional error associated with the maximum fractional error associated with the product of a two quantities is always equals to the sum of what? The sum of fractional error. The sum of fractional errors of two individual quantities is called as a errors in product. Okay, then go for the next one. Errors in division. Errors in division or in quotient. Errors in division or quotient. Errors in division or in terms of quotient. It is also called division rule or is also called as a quotient rule. It's also the earlier what we discussed in here. This is called as a product rule. It is also called as a product rule. So now let's start this. Errors in division. Errors in division. Division. This division is also called as quotient. This is also called as what? Quotient rule. It is also called as, it is also called as a quotient rule. It is also called as a quotient rule. Quotient rule. It is also called as a quotient rule. It is also called quotient rule. Now let's have this. Let's division rule. Consider the corresponding physical quantity which is going to be taken as x equals to a by b. This is for the first condition we got. Then apply the same procedure. There is no change. We know that a and b are the corresponding two physical quantities. The error associated or the error linked with the a and b is given as along with this product here. What I get now here, this value will be x plus or minus delta x equals to x plus or minus delta x equals to what I get? This is a plus or minus delta a whole divided by the delta always indicates very small. That's why it is called as an absolute error. Absolute error, whatever we obtain, once after the difference making that we get there is a very small value. That's why we mentioned as a delta. This is b plus or minus delta b. Plus or minus delta b. Apply the same procedure what we followed in the previous video. So that's apply the same condition. Take x as a common. If I take x common, what I get now here? 1 plus or minus delta x by x. This is equals to, take a as a common, what you get? This is a into bracket 1 plus or minus delta a by a whole divided by, take b as a common. This is b common 1 plus or minus delta b by b. Then simplify this, what you get now? So this is x into big bracket 1 plus or minus delta x by x. This is equals to a by b into bracket 1 plus or minus delta a by a whole divided by 1 plus or minus delta b by b. What is a by b? You see, a by b is called as what? X. From equation 1, substitute x into big bracket 1 plus or minus delta x by x. This is equals to x into big bracket 1 plus or minus delta a by a into, look at this step carefully here, guys. Look at this step carefully here. What is the power of this? Is plus 1. If this plus 1 goes to the numerator, it will become what? Minus 1. Okay, got it clearly, everyone? See, this term in denominator, if it goes to the numerator, the power will change. Therefore, this can be written as 1 plus or minus delta b by b whole to the power minus 1. Then you see from LHS and RHS, what are the similar terms we have? There is a x. This x and this x will be cancelled. The next one, 1 plus or minus delta x by x. This is equals to, again, this is 1 plus or minus delta a by a into, just look at carefully over here. This is 1 plus x. 1 plus x whole to the power 1 plus x whole to the power n. That is called as a binomial theorem. This is going to be resembles to the binomial theorem. Then according to the binomial theorem, the sign of the power, whatever is there, you just replace over here. That's all. The sign of the power, whatever you have, that replace over here. Then what do you get now here? From binomial theorem, 1 minus or plus. Because the plus is replaced by what? Minus. Minus into minus, it becomes plus. Then delta b by b it is. Delta b by b. Because from binomial theorem, the binomial theorem is what you have? 1 plus x to the power of n. 1 plus x to the power n. And that is equals to 1 plus, this is equals to 1 plus n of x. 1 plus n of x. N is how much it is? 1. N is equals to how much you have? 1. And what is the sign you have? Minus. Then this sign will be multiplied over here. This is we call as a x, and there is a n. Power is -1. That's all. Okay. Then simplify this. Again, follow the same procedure. There is no need to be change anything. Then multiply this 1 to this bracket. Then delta a to this bracket. What do you get? 1 plus or minus delta x by x. This is equals to 1 ones are 1. Then minus or plus. You can write down replace. There is no meaning over here. And I will write this plus or minus as it is again. There is no change. This is delta b by b. Delta b by b. Then again plus or minus delta a by a. Again 1 answer this value will be again plus or minus delta a by a into delta b by b. Then you see from LHS and RHS. The LHS and RHS, what do you get now? 1 minus of 1 plus or minus delta x by x. This is equals to delta a by a plus or minus delta b by b plus or minus. What do you get now again? It's a delta a by a into delta b by b. That plus 1 and minus 1. The plus 1 and the minus 1. The term will be get cancelled over here. You get what? There is a plus or minus delta x by x. This is equals to again. You see delta a by a plus or plus delta b by b plus or minus delta a by a into delta b by b. You see from the earlier video, the earlier session, earlier condition, what we discussed there. This term is very small. Again, very small term. If it is a very small term, then it is neglected. Hope you get the condition clear here. This is very small, and hence it is neglected. Hence it is neglected. Then what is the condition we can get here? The condition is that is delta x by x. This is equals to delta a by a plus delta b by b. This is error in the division or error in the quotient. This is we call as error in the quotient or error in the division. Then what is the rule you can apply? The rule can be applied as what? The maximum fractional error. You can get just that. See, look at the carefully here. The maximum fractional error associated with the two physical quantities are associated with the given physical quantity is always equals to the sum of fractional error of individual quantities. Fractional error of individual quantities is kind of errors in division. Errors in division. This is we call errors in the completely division. So just I will recall things what we discussed here. So just x is equals to a by b equation 1. Then error associated with this x is how much? Delta x. Error associated with this a is how much? Delta a. Error associated b is how much? Delta b. Where delta a and delta b are called as what? Absolute errors. These are called as what? Absolute errors. And remaining the same step, whatever we followed in the product rule, everything will be same steps. Just the one new step what we got here, this is we call as a binomial theorem. From binomial theorem, so this is the theorem we are applying. What is the theorem we have? 1 plus x. 1 plus x we have. Okay, x. And 1 plus x we are applying. And this power is how much you have here? N is equals to how much? -1. Multiply over here -1. Keep it x as it is. So plus is replaced by what? Minus. Minus is replaced by what? Plus. Because minus into minus plus. Minus into minus plus, plus into minus, minus. And that's why we wrote this is minus by plus. Again, for simplicity purpose, it changed over there. Plus or minus as it is, again, there is no change the value. For again, same procedure. Again, -1 and +1 will be cancelled. And we got there is that. This is we call the maximum fractional error associated in this process is always equals to the sum of fractional error associated with the two physical quantities. Is called as a quotient rule. Quotient rule. Quotient rule is also called as a division rule. This is we call as error in division. Earlier we got error in multiplication, error in product. This is we call error in division, error in quotient. The next one, error in powers. This is most important. Remember, error in powers. Error in powers. We can go for the next heading there. The errors which is obtained in powers. What are the next heading? Errors in power. Okay. Errors in power. Errors in power. Errors in power. Okay. In this powers, here we consider the same procedure will be applied. For example, if consider a quantity, consider a quantity. Consider a quantity. That is what we have. The quantity will be, again we are using z is equals to a to the power n. I will use this z is equals to a to the power n. Okay. Z is equals to a to the power n. Call this equation number 1. That's all. How much the error associated with z can be given as, and how much the error associated with the a can be given as. So this is z plus or minus delta z. This is equals to, this is a plus or minus delta a into whole to the power n. A plus or minus delta a whole to the power n. This is the error associated with the a value, the error associated with the z value. What is n? N is the power, a is the base. Then what is delta a? Delta a is called as the absolute error, error associated with a given value of a physical quantity. Then same procedure again, no need to be change anything. Take z as a common, here a as a common. What you get? This is z common, 1 plus or minus delta z by z is equals to a. Remember, we can't take a separate common because power is there. You take along with that a to the power n into big bracket 1 plus or minus delta a by a whole to the power n. What is a raised to n? A raised to n is called as what? Z. From equation 1, this is z into 1 plus or minus delta z by z. This is equals to z into 1 plus or minus delta a by a whole to the power n. And you see from LHS and RHS, you see from LHS and RHS what again? This z and z will be cancelled. Again, what you have? 1 plus or minus delta z by z. This is equals to 1 plus or minus delta a by a whole to the power n. A whole to the power n. Then next step, for the simplification, what the condition will be applied here? Then a raised to, we can apply the condition for this from the binomial theorem. What the binomial theorem will be applied? From binomial theorem, we can write from binomial theorem, this is 1 plus x whole to the power n is equals to 1 plus x whole to the power n is equals to 1 plus nx, 1 plus nx. This is we call as a binomial theorem. Then from binomial theorem, this is the corresponding value we have. So this n will be multiplied over here. What do you get now? See, 1 plus or minus delta z by z. This is equals to 1 plus or minus n into delta a by a. Then from LHS and RHS, what do you find? The similar term, take it one side. 1 minus 1 plus or minus delta z by z. This is equals to plus or minus n delta a by a. Then plus 1 minus 1 get cancelled. Then what's the term remaining there? The term remains over here is delta z by z. This is equals to n delta a by a. This is called error in power. This is we call error in power. Then what is the rule can be applied? The rule applied is the fractional error in the nth power of a quantity is the fractional error in the nth power of quantity, fractional error in the nth power of a quantity, of the power in the nth quantity is the n times of a given n times of fractional error of quantity. This is called error in power. Remember, this is we call as a error in power. Okay. Hope we got the complete information regarding this errors, and we can just recall things what we discussed up to today's class. The first heading we went with, there's a brain map. We call as a brain map for us. What's the brain map for these errors? Here we have a simplest way to analyze about the whole chapter in one shot. What that one shot will indicates here? It means within a fraction of a second, we can easily analyze the whole chapter there. Okay, that's why we have the condition. Okay, what is the first one we have? There is a heading of error. First we went error. It is an true value minus measured value. True value minus measured value. The error may be positive or may be negative. Error may be positive or may be negative. Then after this, how many types of error we discussed? Two types of errors. One is called systematic error. Second is called random error. Random error. Systematic error whose cause is known. Cause is known. For random error, cause is unknown. The cause is unknown. Cause is unknown. Then after the systematic errors, there are types of systematic error. The first one, it's a personal error. Personal error, it is due to mistakes which is done by the observer. Then second one, environmental error. Environmental error. The next one, due to instrumental error. Instrumental error. The next one after this, after instrumental error we have personal error, environmental error, instrumental error, wrong observation pattern, wrong observation or a wrong experimental technique. These are the few methods which will be discussed in the systematic error, and these errors can be analyzed and rectified by following three ways. What is the first step? The first step is by choosing the better instrument, by choosing or by selecting better instrument. Number two, using a better experimental techniques or better observation techniques. Better observation techniques will be applied. Third one, there is an removing personal bias. Personal bias will be removed. Then after that, we went with the two statements over here. One is called accuracy, and second is the precision. The closest approach, we call as the closest approach or very closest value is called as what? Error. The closest value which is going to be called as what? Error. Accuracy. What is accuracy? The closest measurement value. The closest value is called as what? An accuracy. And what is the precision? The precision is always going to be referred as the resolution or limit to which the quantity can be measured is called as the precision. So after finding these two, we went with the random errors. After finding the values of a random error, then we went with the types of errors there. Again, here the first one we have absolute error. Absolute errors. Then second one, after absolute error, it's a mean absolute error. Mean absolute error. And before that, what we went? It's a true value or a mean value. It's true value or a mean value. True value or a mean value. Mean value. It is denoted as a mean. True value is always denoted as a mean. And absolute error is denoted as a modulus of delta A mean. And this value will be taken. In NCERT has been mentioned that this value is equals to A1 minus A mean is given. This is for maximum term we can write there. For maximum we can write for this. And for minimum, for generalized condition purpose, what we made A mean minus A1 we made. Okay, don't make it confused. Both methods are correct. Both conditions are also correct. Both analysis are also correct for the measurement of an errors. For maximum value, what we can write here? So this is modulus of delta A mean can be written as A1 minus A mean. This is also correct for maximum. For a general condition, for what we can write for this? Delta A mean is equals to A mean. That's a true value minus measured value. That's all. Both methods are also correct there. Okay, don't make it confused. Hope you got the complete information. Then here this is for the corresponding. Next we have absolute error. This is delta A is equals to A mean minus A1. Mean absolute error delta A mean. This is delta A mean. We can write. The next one we have the next after this. There is an relative error. Relative error is equals to. Relative error is always defined as what? The relative error of a given value can be given as it's a delta A mean divided by mean value or a true value. This is mean value. Mean value or a true value. Then lastly we have percentage error. Percentage error is always equals to this value of multiplication. That is delta A mean modulus. This is we call as the corresponding percentage error. After finding this percentage error, we went with the propagation of errors. Propagation of errors are all going to be divided into the following ways. Next heading we have there is a propagation of errors. Propagation of errors. The propagation of errors, how we can write this? The first propagation of error is due to sum. The second due to propagation is difference. some difference. Then third, what you have? The third one is going to be called as what? An product. And the fourth one, today we discussed that. Fourth one is division. Division. And lastly, today's last class at the point we discussed about that is we call as the power. Error due to power. These are the 5 types of propagation of errors we discussed there. Okay. This is we call as the complete brain map of the small chapter called as error here. Okay. So first, what we went? What is error? Error is always called as uncertainty associated with any measurement of a physical quantity is called error. It is also defined as true value minus measured value. Error may be positive or may be negative. The errors are of 2 types: systematic error, random error. The cause is known, cause is unknown. The types of errors, how to minimize the errors. Then again we have the 2 simple statements: accuracy and precision, closest value, the resolution or the limit to which the quantity can be measured. Then here absolute error, mean error, relative error, percentage error. There is propagation of errors are following 5 types: errors due to sum, errors due to difference, errors due to product, errors due to division, errors due to power. These are the 5 steps. You remember, the whole error chapter looks like so simple and the easiest one. And what are the formulas we applied here? The errors in sum, what the formula we applied? Then the errors in sum is given as delta Z is equals to delta A plus or minus delta B. This is for the error in sum. This is due to error in sum. Or what the formula we applied? Directly we write just there is an errors due to in sum is given as what? Delta Z is equals to delta A plus delta B. And in difference, what you wrote? Delta Z is equals to. Again the same result we got, delta A plus delta B. Errors in difference. Error in product now. Now only we solved error in product. What is the error in product formula? We have fractional error. Error in product or quotient, what we have? There is a fractional error. Delta Z by Z. This is delta Z by Z. This is equals to delta A by A. Delta A by A plus delta B by B. This is we call error in product. We call as error in product. Similarly, yes, is it right? You see, there is a product I am talking. I am talking about there is a product. Product means hardware, right? So this is error in product. Can I put the dot or plus? Remember, can I put the dot or a plus? That's important. Product stand always there is equation, doesn't change. There is a sum of 2 fractional errors. Remember, there is a sum. Sum means there is an addition. Okay. Similarly, for division, the same answer we got. There is an delta Z by Z. This is equals to delta A by A plus delta B by B. This is for error in division. Error in product, error in division. For error in product, for error in the product is, what are the formula we got? There is an error in product. Delta Z by Z is equals to n times of delta A by A. This is we call error in the power. This is we call the complete chapter which is related to the error. This is we call brain map of the chapter test. So guys, this is complete information which is related to the errors, and there is a complete chapter which is going to be completed. And here for the last one, we can write for general case. If we have, there is an for general rule for the maximum fractional errors for the Z value. For general rule for, you remember for this is for solving numericals. Okay, general rule for solving, general rule for solving, maximum fractional error, maximum fractional errors. The same process, no change. The general rule for solving the maximum fractional errors. The equation is given as z is equals to, so this is z is equals to a to the power p, b to the power q, and c to the power r. A to the power p, a to the power p, b to the power q, c to the power r. And now we can write for the general rule for this. The error associated with this, how much we have? It is delta z by z. This is equals to p into delta a by a plus q into delta b by b plus r into delta c by c. This is for maximum errors. And this is for maximum errors associated with the fractional. Okay, the general rule for maximum errors for the powers. Okay, then percentage error for this delta z by z into 100 multiply by 100. That's all. That's for percentage error. Then similarly, p into delta a by a into 100 plus we go for the second one, that is q. So q into delta b by b into 100 plus r into delta c by c into 100. This is for percentage error. General formula we got. This is for percentage error. This is for general cases. You remember, this is the general case formula. For this, here we complete the complete chapter of errors. Okay, thank you.